The universe wasn't always filled with stars and galaxies. For a long period, it was a vastly different place. Imagine a time of profound darkness. This period, lasting hundreds of millions of years after the Big Bang, is known as the Cosmic Dark Ages. During this era, the universe was a hot, dense soup of particles. These particles, mainly protons and electrons, zipped around in a chaotic dance. Light couldn't travel freely in this cosmic fog. It constantly bumped into these particles, getting scattered in all directions. The universe was expanding and cooling. This cooling was crucial. Eventually, the universe would become cold enough for atoms to form. This transition marked the end of the Dark Ages and set the stage for the universe we know today. Understanding this period is key to unraveling the mysteries of the early universe. As the universe cooled, protons and electrons slowed down. They began to combine, forming the first atoms, mostly hydrogen. This event, roughly 380,000 years after the Big Bang, is called recombination. With fewer free electrons to scatter light, the universe became transparent. Light could finally travel freely across vast distances. This first light, released during recombination, still exists today. It surrounds us as the cosmic microwave background radiation. Think of it as an echo of the Big Bang. This faint afterglow carries valuable information about the early universe. It tells us about its composition, temperature, and even its shape. By studying this radiation, we can peer back into time. We can learn about the conditions shortly after the universe was born. The universe, now filled with neutral hydrogen, was still a relatively simple place. Gravity began to slowly pull matter together, forming giant clouds of gas. Inside these clouds, denser regions started to collapse under their own gravity. These collapsing regions became hotter and denser, eventually reaching temperatures and pressures high enough to ignite nuclear fusion. This marked the birth of the first stars, much larger and brighter than our sun. The ignition of these first stars, hundreds of millions of years after the Big Bang, brought an end to the cosmic darkness. This period is known as the Cosmic Dawn. These stellar pioneers played a pivotal role in shaping the early universe. They were the furnaces where the first heavy elements were forged. The intense radiation from the first stars had a profound effect on the surrounding neutral hydrogen. These energetic photons stripped electrons from the hydrogen atoms, ionizing them. This process, called reionization, transformed the universe once again. Reionization wasn't instantaneous. It occurred gradually, creating bubbles of ionized hydrogen around the first stars and galaxies. These bubbles grew and eventually merged, filling the entire universe with ionized gas. This reionization era marks a turning point in cosmic evolution. It paved the way for the formation of larger structures like galaxies and galaxy clusters. The interplay of gravity, light, and matter continued to shape the universe we see today. It eventually gave rise to planets, stars, and ultimately life itself.